Hello, and welcome to Summarize Science, where we break down complex research into simple terms. Today, we're looking at a paper that could completely change how we use 3D printers. 3D printing is amazing, but the path from an idea to a physical object has always had a major roadblock. You need a digital 3D model. Creating these models in computer-aided design, or CAD software, is slow, requires a lot of skill, and is a huge barrier for most people. Even small changes can mean going back and manually updating the model, which is a massive pain. To solve this, researchers at Carnegie Mellon University created Image-to-Code. It's an end-to-end system that generates the final printer instructions, called G-code, directly from a 2D image. You can give it a photo of an object or even a simple hand-drawn sketch, and it figures out the rest. It completely skips the need for a CAD model. So how does it work? The core of the system is a powerful AI called a Diffusion-Transformer model. This AI was trained on a massive dataset of over 100,000 pairs of 2D slice images and their matching G-code instructions. By analyzing all this data, it learned the fundamental relationship between a 2D shape and the complex toolpaths needed to print it. It learned how to create the outlines and, more importantly, how to fill in the object with structurally sound patterns. And the results are incredible. The system can take photos of real-world objects, like this bowl or this makeup compact, and generate a printable version. It also works on hand-drawn sketches, turning rough doodles into clean, physical parts. This shows the AI can generalize its knowledge far beyond the clean, synthetic data it was trained on. What's even more fascinating is that the AI doesn't just copy what it's seen before. In some cases, it generates completely novel infill patterns that are different from the original training data, but still create a valid, strong part. This means the model has learned the underlying principles of printing, not just memorized examples. The researchers also found that the toolpaths generated by the AI were, on average, over 2% shorter than those from conventional software. This suggests the AI is learning to create more compact, efficient paths, potentially saving print time and energy. So, let's recap the important points. This research introduces a new framework that generates 3D printer instructions directly from a 2D image, skipping the difficult 3D modeling step. It works with photos and sketches, can invent new printing strategies, and can even create more efficient toolpaths. This could make 3D printing dramatically more accessible, allowing anyone to turn a quick drawing into a physical object. Looking to the future, this technology could be integrated with other AI systems. Imagine telling a printer, make this part, but optimize it for strength or print this as fast as possible. This work is a huge step towards a future of truly intelligent, accessible, and adaptive manufacturing. Thanks for watching Summarize Science.